Hi, in this video we're going to talk about upper and lower bounds. Why do we need upper and lower bounds? In reality, no measurement is perfect. No measurement is completely accurate. Every measurement is between two limits, okay? And every instrument we use to measure has its limitations. Okay, so I'll show you with a small example. Okay, a very easy example. Imagine we have a ruler which measures centimeters. Okay, and we have 1 centimeter here, 2 centimeters here, and 3 centimeters here. Okay, so I'll extend this, just give me a second. Okay, so imagine we're measuring something with this ruler and we have an object that gets to here. Okay, so what would we say that this object measures? Well, we would say that it measures more or less 2 centimeters. Why? Because the smallest thing we can measure in a ruler is 2, and we don't really know if this is 1.8, 1.9, so we approximate it to 2, okay? That means, and why don't we approximate it to 1? Because we more or less know that 1.5 is here, okay? And we know that 2.5 is here, so we know that this is a bit more than half than 1.5, so we approximate it to 2. Okay, imagine we had another object and we tried to measure it, and it was something like this. Again, we would say that the upper object would measures 2 centimeters. The objects are different, but my instrument doesn't have enough accuracy to measure the difference. It only measures 1 centimeter, and the difference is smaller than my accuracy. So the first object and the second object, I would say they measure 2. Okay, so so any measurement on over 1.5, which is here more or less, we would approximate it to 2. So this is what we call our lower bound. Anything under that would be approximated to 1. Anything over that would be approximated to 2. It's our lower bound for our measurement, which was, remember, our measurement was 2 to the nearest centimeter. And 1 centimeter is our accuracy. Our instrument cannot measure more than 1 centimeter. Okay? And when would I approximate our measurement to 2 above 2? Well, anything below 2.5. Really, any measurement would be up until 2.49999 recurring within an infinite number of 9s. But we don't write that, so we write the upper limit as 2.5. Anything that goes in 2.5 would be approximated to 3. Anything below 2.5 would be approximated to 2. So that's why we call 2.5 our upper limit. And as it does not include 2.5, because 2.5 would be approximated to 3, when we write our upper and lower bounds as an inequality, we do include the lower bound, because the lower bound is approximated to my 2, but we don't include, and this is important, our we don't include our upper bound, because our upper bound, if a measurement would be our upper bound, it would be approximated to the next number. Okay, so it is very important to realize that the lower bound is included in our inequality, but the upper bound is not. Okay, because it's really 2.4999999, but we don't write that. Okay, so upper and lower bounds give us limits to where our real measurement would be, and they have to be provided because our instruments are not perfect and they have an accuracy. Once we understand this, to do the exercises, we can follow a procedure, which is we find out the accuracy. I'll write it down here for you. Step 1, find out your accuracy. Step 2, half your accuracy. Step 3, lower bound is our measurement minus our accuracy divided by 2, and our upper bound is our measurement plus our accuracy divided by 2. Okay, so let's go and look at some exercises. We've been told that we have something has been measured, and it measures 57.7 rounded up to the 1 decimal place. And we are asked to find the limits, the upper and lower bounds for that measurement. Okay, 1 decimal place means 0.1, 0.2, 0.3, 0.4. So the accuracy of our instrument is really 0.1. Okay, that's our accuracy. Step 1, we found our accuracy. Step 2, we have to divide it by 2. So 0.1 divided by 2 is 0.05. Okay, and now we're going to find our limit, our boundaries. Our lower boundary was our measurement minus 0.05. So that means this is 57.65. That's our lower bound. Our measurement can be anything between 57.65 and, without included, our measurement plus that 5. So that's 57.75. So this is the lower bound, and this is the upper bound. Okay? And as I said, written as an inequality where we don't include our upper bound because we don't get there. Okay, it's anything under our upper bound. Next exercise, a baby weighs 7 kilos. To the nearest kilo, work out the upper and lower bounds. So now my accuracy is 1 kilo. The way I was using can only measure 1 kilo, 2 kilos, 3 kilos. So step 2, 1 kilo divided by 2 is 0.5 kilos. And then how do we calculate our upper and lower bound? 7 minus 0.5 is 6.5. 7 plus 0.5 is 7.5. Okay, again, kilos and kilos if you wanted to include the unit there. So this is my lower bound, and this is my upper bound. Okay, so it's very easy. Understand that this is related to the accuracy of our instruments that we can't measure perfectly. We need to know between which values our measurement would really be, and that we get the accuracy divided by 2, subtracted to the measurement to find the lower bound, and add it up to our measurement to find the upper bound. I hope it helps.